Hello, amazing people, students, wherever you're watching this from all over the world. I'm super excited to have you on the third video in this series where we're dealing with the topic of the mole. And here we're going to be talking about the golden triangle. So without further ado, let's get into details about what this is and what it entails. So this golden triangle is simply an imaginary triangle that enables you to move between the concepts of the mole, the mass, and the number of particles of a substance. Now, in chemistry, when you are able to move from the mole to the mass of a substance, from the mole to the number of particles present, or even from the mass to the number of particles present, then you are able to solve a variety of questions, which is what we want to achieve by the end of today's video. So I'm going to be showing you how you can shuttle in between all these concepts, and I want you to stick around till the end of this video. So the first among all three of them is the moles. Now, this is a very common exam question for examinations like WAEC, NECO, JAMB, and other terminal examinations like that. When you are asked to calculate the number of moles of a substance and you are given the mass and the molar mass, this formula is what you use. The moles of a substance is given by the mass divided by the molar mass. Now, here's a relatable example. A majority of people who'd be watching this video actually enjoy rice. So if a cup of rice costs, let's say, 100 naira per cup and you have 500, and I say, hey, how much would you be able to buy using the money that you have? You would simply say the money that you have, which is 500, divided by the cost of each cup, which will give you 5 cups that can be bought with your money. In the same way, when you have or when you want to calculate the number of moles of a substance, you simply divide the mass by the molar mass. It is as simple as that. It doesn't get simpler than that. So let's move into a number of examples and see if we can make this clearer. The example says find the number of moles present in 36 grams of water, which is H₂O. So first things first, we want to write out our formula that says the number of moles of a substance is given by the mass divided by the molar mass. Okay, so we have the mass to be 36 grams, but the molar mass is not given. Not to worry, we know how to calculate the molar mass of a compound. The molar mass of a compound is simply given by adding all the relative atomic masses together. So we have H₂O. The relative atomic mass of hydrogen is 1, and we have 2 atoms of hydrogen. So that becomes 1 times 2 plus the relative atomic mass of oxygen is 16. And we have just 1 atom of oxygen, so it becomes 16 multiplied by 1. Altogether, we have 2 plus 16, which gives us 18 grams of water. As the molar mass, 18 grams per mole. So now the next thing to do would be to plug in our values into the formula. The number of moles, remember, is equal to the mass, 36, divided by the molar mass, which is 18. We end up having 2 moles of water present. Did you see how simple that is? And did you see how we took step-by-step processes to arrive at our final answer? So that is for calculating the number of moles of a substance. The next thing we want to do is to see how we can calculate the mass of a substance when we are given the value of the moles. Now, the formula for doing that is given on the screen right now. The mass of a substance is equal to the number of moles times the molar mass. So let's go ahead and solve an example to see if we can make this clear. The question on the screen right now says, what is the mass of 3 moles of CO₂. Remember, the formula says mass is equal to moles, the number of moles, multiplied by the molar mass. The number of moles are 3, and the molar mass of CO2. How can we calculate that? So we have CO2. Now let's go ahead and calculate the molar mass of CO2. Carbon has the relative atomic mass of 12, and there is just one atom of carbon, so it is 12 times 1. Oxygen has the relative atomic mass of 16, and we have two atoms of oxygen, so it becomes 16 times 2. Altogether, we have 12 plus 32. 12 plus 32 gives us 44 grams per mole. This is the molar mass of carbon. So therefore, we can plug that into our formula. The formula says mass is equal to the number of moles, 3, multiplied by the molar mass, which is 44. Give me a moment to punch our calculator. So we have 3 multiplied by 44. That gives us 132 grams per mole of CO2. So did you see how that was calculated? When you're calculating for mass, it's actually in grams. So gram per mole is not the correct thing. So let me rewrite that. 132 grams of CO2. So did you see how that was calculated? I hope you're enjoying every bit of today's lesson. If you are, please do well to like, share, and subscribe. It means a lot to me. Now, finally, you can actually convert from number of moles to number of particles. This is where we move to Avogadro's number and involve it in the calculation. So remember, in the introductory video of this series, we talked about 1 mole being equal to 6.02 times 10 raised to power 23 particles. So it therefore means that when you want to calculate the number of particles present, you would simply say the number of moles that are given multiplied by the Avogadro's number, which is this. So let's go ahead and solve one example. The example says, how many molecules are present in 2 moles of oxygen? So let's take this step by step. The formula says number of particles is equal to the number of moles multiplied by Avogadro's number. Let me just use an acronym, AN. So now the particles that we are calculating in this case are molecules. How many molecules are present? We do not know that, but we know that the number of moles present are 2. And Avogadro's number is 6.02 times 10 raised to power 23. So if we want to do justice to this, we simply say the number of particles present equals 2 multiplied by Avogadro's number, 6.02 times 10 raised to the power of 23. So when we punch our calculator, 6.02 times 10 raised to the power of 23 multiplied by 2, that gives us 1.204 times 10 raised to the power of 24 molecules. That's the number of molecules that are present in 2 moles of oxygen. Now, did you see how each step was carried out, and did you enjoy every bit of it? I'm so sure you did. I am so sure you did. So now we can even take it a step further and say, if we're given the number of particles, we can convert it into number of moles, and there is a formula to handle that as well. So let's say we have number of particles given, and you want to find the number of moles. You would simply say the number of moles is equal to the number of particles divided by Avogadro's number, which is 6.02 times 10 raised to power 23. Now here is an example on the screen. Find the number of moles present in 3.01 times 10 raised to power 23 particles. So let's impute our variables into the formula. Number of moles, therefore, will be equal to the number of particles which we were given, 3.01 times 10 raised to power 23, divided by Avogadro's number, which is 6.02 times 10 raised to power 23. Huge, huge numbers. So let's punch our calculators. 3.01 times 10 raised to power of 23 divided by 6.02 times 10 raised to the power of 23. That gives us that gives us 0.5 moles. So allow me to write that down. 0.5 moles. So are you seeing how each step is being carried out? Simple, straight to the point, and concise. So now, some examiners that are setting questions for you can say, okay, let's take it a bit further and become more tricky. They can now say, okay, change the mass of a substance into number of particles, or change the particles into mass. What do you do? It is as simple as that. You just simply change the mass of that substance into number of moles, and then from number of moles, you can change it into the number of particles. It is as simple as that. Okay, so let's take some examples to show you what exactly I'm talking about. This question on the screen says, how many particles are in 18 grams of H₂O? So the first thing we want to do is convert these 18 grams into number of moles. And how do we do that? We know that number of moles is equal to the mass of a substance divided by the molar mass of that substance. So therefore, the number of moles will be equal to the mass, which is 18 grams, divided by the molar mass of water. We've done that earlier. The molar mass of water is also 18. So therefore, this gives us 1 mole. Now that we have the number of moles, we can now use that to calculate the number of particles that are present. Remember, number of particles present is equal to the number of moles multiplied by Avogadro's number. And Avogadro's number is 6.02 times 10 raised to power 23. And the number of moles present here is 1. So therefore, the number of particles becomes 1 times 6.02 times 10 raised to power 23. And therefore, the number of particles become 6.02 times 10 raised to power 23 particles. It is as simple as that. Now, can I give you an exercise to try out your hands on? I can hear you saying yes. Okay, so now let me tweak the variables a bit. If I say how many particles are present in 36 grams of H₂O, what would be the answer? I'd like you to drop it in the comment section. I look forward to reading them and answering them as soon as you do. So up next, we're going to be looking at the topic moles and gases. It is something that I want you not to absolutely miss. I know you enjoyed every bit of today's lesson. If you did, do well to like, share, and subscribe. And I will see you in the next video. Thank you for following through and stay blessed.